Beware, because there is another blow to Big Bang. James Webb Telescope detects a structure that should not exist. This anomaly contradicts our understanding of the universe's origins and raises profound questions. The field of astronomy has always been a source of intrigue and fascination, often revealing events that challenge our current understanding. Recently, a team of researchers from the University of Minnesota stumbled upon a galaxy so peculiar that it could potentially call for a radical change in our existing theories. The James Webb Space Telescope, a significant player in this new discovery, is currently functioning at an optimal level for research. The capabilities of this instrument are truly remarkable. It can gather around 10 times more light than its predecessor, the Hubble Space Telescope, and exhibits a particular sensitivity towards longer, redder wavelengths in the infrared spectrum. This opens an entirely new window for researchers, allowing them to delve deeper into the intriguing history of the cosmos. However, to fully grasp the early universe, we need to journey back to a time before the concepts of time and space as we know them were even established. According to the theory of cosmic inflation, the universe was initially birthed from the Big Bang as a singularity, a state of infinite density and heat. When the universe was a mere 100 billion trillionths of a second old, a phase of rapid expansion occurred, known as inflation. During this period, space itself expanded at a rate surpassing the speed of light. This is yet another blow to Big Bang. James Webb Telescope detects a structure that should not exist. The universe underwent a remarkable change in that split second. From a size comparable to a subatomic particle, it grew to one roughly the size of a golf ball, an increase of at least a factor of 90. The expansion of the universe slowed after this stage, but never stopped entirely. Matter was eventually created as the expanding universe cooled down and condensation nuclei formed. After the Big Bang, the universe was filled to the brim with all kinds of particles: neutrons, protons, electrons, anti-electrons, photons, and neutrinos. For light to have traveled through the universe, it had to be dark for about 380,000 years. Subsequently, after this 380,000-year period, matter began to cool and gradually form atoms. However, at this juncture, stars and other luminous objects had not yet taken shape, plunging the universe into complete darkness. Fast forward to 400 million years after the Big Bang, we find ourselves at the threshold of a new epoch. This period in the evolution of our universe is known as the Age of Reionization. Scientists hypothesize that galaxies underwent a form of adolescence between 1 and 2 billion years after the Big Bang, with their formation initiating in the first billion years. This period spanned over 500 million years. Yet, in a surprising twist, the James Webb Space Telescope has revealed the existence of 6 fully formed galaxies just 500 million years after the Big Bang. This discovery indeed poses a perplexing problem. More than 13 billion years ago, an international team, led by scientists from the University of Minnesota, leveraged the powerful observations from the James Webb Space Telescope to uncover an unusually small galaxy. This galaxy was creating new stars at a rate that defies its diminutive size. As one of the smallest galaxies ever discovered at such a tremendous distance, it may offer critical insights into the first galaxies that emerged after the Big Bang. This breakthrough discovery, while challenging, broadens the horizon of our understanding and encourages us to delve deeper into the cosmos's most enigmatic secrets. It urges us to reevaluate our existing theories and seek knowledge in places we haven't ventured before. The universe continues to be a source of endless fascination and wonder, and as we uncover more of its secrets, we continue to realize just how much more there is left to learn. As we stand on the cusp of these exciting times in the world of astronomy, we can look forward to more intriguing revelations about our vast cosmic home. Astonishingly, the rate at which this particular galaxy forms stars can be likened to our own Milky Way, even though it occupies only a millionth of the Milky Way's volume. Scientists believe that the galaxies near us have undergone substantial changes since the universe was young, meaning what we see now may not accurately represent the past. The mystery of how the universe's first stars and galaxies came into being might be unraveled by investigating these galaxies. For now, the inception of the universe remains an enigmatic subject, cloaked in mystery. However, recent observations are progressively adding pieces to this cosmic puzzle. Findings from the James Webb Space Telescope suggest that the universe, especially its early stages, was even more peculiar than we initially thought. Webb has been instrumental in uncovering distant galaxies and a black hole that's nearly as old as the universe itself. The telescope's incredibly sensitive detectors aided researchers in locating what they believe is the oldest black hole in the universe. It's mind-boggling to conceive that a supermassive black hole, which is 10 million times larger than our Sun, existed at the heart of a galaxy just 570 million years after the Big Bang. Scientists estimate the age of the universe to be around 13.7 billion years. JWST has unveiled a supermassive black hole that's 10 million times the mass of the Sun, and it's actively growing as it feeds on the matter surrounding it. This incredible discovery was made only 570 million years after the Big Bang, but researchers are hopeful that this record won't stand for long. This black hole was discovered in a galaxy known as CRS-Den 19, an early universe galaxy previously identified as EGSI 8. The rapid growth of black holes that fueled the onset of the cosmic era is one of the grand mysteries of the early universe. The discovery of this black hole might help illuminate this mystery. We've found the most distant active galactic nucleus and the earliest black hole we've ever discovered, said one of the astronomers involved in this groundbreaking research. Scientists were initially drawn to CRS-Den 19 because of the light emitted from the formation of ancient stars. This emission, known as Lyman alpha emission, is thought to come from the ionization of neutral hydrogen during star formation. In the early universe, neutral hydrogen was abundant, acting like a fog and stopping light from traveling freely. When this hydrogen was ionized, it created a clear path for light. Our knowledge about this era, known as the Rionization era, is currently limited. It's challenging to see that far back in time, but we know it occurred about 1 billion years after the Big Bang, or approximately 13.8 billion years ago. CRS-Den 19 and a small group of other super-early galaxies are ideal subjects for this type of investigation. This galaxy, which is the oldest and most distant known to date, was first identified in 2015 through data collected by the Hubble Space Telescope. Subsequent observations confirmed its existence but offered few additional details. Due to the universe's expansion, the earliest light in the universe has shifted so far into the infrared part of the spectrum that only a powerful dedicated infrared instrument like JWST can explore it. CRS-Den 19 was chosen for further study by the JWST because it is the brightest of the Hubble-era galaxies. For just an hour, the telescope focused its 4 detectors on the galaxy, sending back a wealth of data that is certain to continue yielding valuable insights into the nature of the early universe. The continual revelations by the JWST are like unwrapping a cosmic gift, offering tantalizing glimpses of a time when the universe was very young, shedding new light on our understanding of the cosmos. The James Webb Space Telescope is truly an eye-opener. It's opening up a brand new world in the spectrum of the universe that we've never been able to see before. Astronomer Rebecca Lawson couldn't contain her excitement. We are seeing aspects of galaxies early in the universe that were previously hidden to us, she exclaimed. The sheer amount of information was overwhelming and took time to comprehend. However, something unexpected caught her eye in the sea of data. The light signature from the galaxy showed both broad emissions that are typical of active galactic nuclei and light from star formation. As she shared her observations with fellow astronomers who also specialized in AGN, a buzz of excitement began to build. In the early universe, when the stars were first being formed, it's more common to find galaxies with either AGN light or starlight. But the coexistence of both is extremely rare. Rebecca noted that even though the black hole's activities have an impact on the emission lines we can observe, the light from the area where stars are being formed still shines brightest in our images. To keep discovering, subscribe to the channel. The idea that a supermassive black hole was growing more than 13.2 billion years ago isn't particularly startling. We have found even larger black holes from the early universe before. The real puzzle for scientists is understanding how these black holes in those galaxies became so massive in such a relatively short time after the universe began. The fact that this black hole was discovered so soon after the Big Bang, roughly 500 million years later, is truly fascinating. These discoveries are causing us to reassess our current understanding of the early universe. The picture is shifting and evolving more rapidly than we anticipated. As researchers, we must be ready to adjust our beliefs and theories to accommodate these new findings. We're not just studying the universe's history, we're actively part of an ongoing discovery process that constantly challenges and expands our understanding of the cosmos. Be sure to click our video on the screen. It explores fresh theories that challenge the Big Bang, reshaping our understanding of the universe's creation and evolution. Dive into these exciting cosmic mysteries with us.